Our lesson today is on segment and angle bisectors, and we also are going to learn to do some constructions. Let's start with our terminology. As we so often do, recall that the point that divides a segment into two congruent segments is the midpoint. And guys, make sure that on your flashcard you have written the segment is divided into two congruent segments as opposed to equal, because this is the definition of midpoint. And remember, I can put the same marking on each of those segments. So for instance, if this is A, and let's say B is the midpoint of AC, then what I know is that AB is congruent to BC, because that's the definition of midpoint. It doesn't say they're divided into equal parts, they're divided into congruent parts. So again, I'm harping on the terminology and symbology, but it's so very important. To divide an angle or segment into two congruent parts is to bisect that angle or segment. So let me just show you something here. If I got an angle here and I divide that into two congruent parts with that ray right there, this is congruent to this, then let's see, if I were to call that A, that B, and that C, then what I would know, because I know the two little angles are congruent, I would know, I gotta label this, I would know that BD is an angle bisector. It divides an angle or a segment into two congruent parts. Okay, so a segment, ray, line, or plane that intersects a segment at its midpoint is a segment bisector. So if I were to come up here to this little drawing that I did and draw a line through that midpoint, then that green line there is the segment bisector. A perpendicular, what, I couldn't think what I was trying to say there. A perpendicular bisector of a segment is a line, segment, or ray that is perpendicular to the segment at its midpoint, of course. So let me go back to this picture. This is a segment bisector, the green one. Now I'm going to draw in red the perpendicular bisector. And I'm going to designate it as being a right angle. That's how I know it's perpendicular, right? You got to remember, I'm pretty sure you've learned this before, that when lines or segments are perpendicular to one another, they form right angles at their point of intersection. So the fact that I have designated this as a right angle tells me that that red line is perpendicular to the blue segment, and the fact that the bisector is going through point B, well, the fact that the line is going through point B tells me that it's the bisector of that segment, because B is the midpoint. All right, we've already talked about this. An angle bisector is a ray that divides an angle into two congruent angles. I drew a picture for you up above. The angle bisector's initial point will always be the vertex of the angle. So in the case of the picture I drew here, that bisector's initial point is B, which is the vertex of that angle. All right, let's do an example. In the diagram, KM is the bisector of the angle JKL. Find the measures of those two angles. Well, let's just write down the angle addition postulate. What does it say? It says that the measure of angle JKM plus the measure of angle, what did they call this? We'll call it MKL. MKL equals the measure of the large angle, which is JKL. Now we're just going to substitute what we know. Let's see, JKM is 2x plus 7. That's right there. 2x plus 7 plus MKL is right here. 4x minus 41 equals, and what do we know about JKL? Oh, guess what? I don't need the angle addition postulate, do I? what should I have done here? I'm not going to erase the angle addition postulate because I actually could use that. What I'm really going to do, and I'm sure some of you were thinking this all along, I'm going to use the fact that Km is the bisector. So what I know, and is going to make this much easier work for me, is that 2x plus 7 equals 4x minus 41, because I know that that bisector divides that large angle into two congruent parts. So what do I get here when I do my algebra? I get negative 2x equals negative 48. So x is 24. And then when I plug in to find my angle measures, what I come up with is that the measure of angle JKM equals 55 degrees. Here's JKM right here, 55 degrees. And the other one they asked me is JKL. So, of course, I know that that's going to be twice 55, right? The measure of angle JKL would be 110 degrees. Okay, so here's a couple of practice problems for you. I want you to pause right here and do these, and then we'll come back and talk a little bit about constructions. All right, so here's what I got for the last two problems in this set. ABD here, I got 75 degrees, and of course that would make this angle 75 degrees as well, DBC. And over here, this one was pretty easy to solve. After I got x equals 10, then I got that both of these angles measure 30 degrees. So if you have any questions, make a note. We'll talk about that next time. What we're going to go into now is constructions. Okay, and you will use two. I couldn't remember what I wanted to write in this blank. So for lack of anything better I can think of, I'm just going to put construction tools. And what your construction tools are that you will use are a straight edge, and that could be a ruler, but you don't use the measurements on the ruler, you just use it to have the straight edge so that you can draw nice straight rays and lines and such. And you use a compass. Both of these things are on your supply list, so if you haven't purchased them already, you need to do so rather quickly. Okay, and when we talk about a geometric figure drawn using a straight edge and a compass, that is known as a construction. You never are going to freehand anything in a construction. You're never going to measure. And if I tell you to construct an angle, you're not going to use your protractor to measure a 90-degree angle. We just use a compass and straight edge. So what I'm going to ask you to do now is, for the rest of today's notes, I don't really have an effective way that I can demonstrate in this recording how to perform these constructions. What I want you to do and need you to do and know that you are capable of doing is to follow the instructions that I've pasted here for constructing congruent segments, or that would also be the same as if I told you to copy a segment. Okay, construct a congruent segment, copy a segment, the same thing. All right, so I want you to follow that, and then I have a section here for you to practice that. Okay, then I want you to go on to the next one where you construct a perpendicular bisector. Follow the instructions. These are very good instructions and they're in your textbook. You can also find all sorts of videos on YouTube and probably even Khan Academy that go through these constructions with you if you need to see someone actually doing it. So construct the perpendicular bisector, and then I left you a space below to practice doing it yourself. Okay, what do we have after that one? All right, we have congruent angles. So I would either tell you to construct a congruent angle or to copy an angle. Those are the same two things that you're going to be doing. All right, so follow the instructions that I have copied for you over here, see what's going on, and then once again I got you a space there to practice that one. And then finally the last one is the angle bisector. Construct the angle bisector, follow the steps, do your best practice. And guys, if you have trouble doing any of this, we'll go through them all tomorrow in class, and I have some classwork that's going to enable you to get a lot more practice. But you should be able to follow the instructions that I have printed here. If you need to find a video on YouTube, there are some excellent ones. I've seen several of them. They're 1 or 2 minutes long. So please practice your constructions, and then we'll work on them some more tomorrow in class.